Okay guys, this is number 10 from worksheet 1.2, day 2. Problems number 7, 8, 9, and 10 on that worksheet are done in a very similar fashion. They're all basically kind of the same problem, but with different numbers and different algebraic expressions. The very first thing that I'm going to look at and really pay attention to when I'm reading this problem is this first statement. J is between H and K. Okay, point J is between point H and point K. Okay, I know it doesn't say point there, but that's what we've been dealing with. We've been dealing with points, lines, and planes, so that's what we really have to start thinking about. So I know that I'm going to need a point H and a point K. And remember, 2 points make a line, so we can connect those two. And I know that J has to be between it. Notice it says between. It doesn't say exactly in the center or in the middle or anything like that. It just simply says that J is somewhere in between H and K on that line. Okay? It doesn't have to be, you don't have to worry about drawing things to scale. You don't have to worry about getting the ruler out or anything like that. You really just want a diagram for you, so you know what you're looking at. Then you basically just have to continue on reading in the problem. I look here and I see that the length of JK is 2x plus 1. It's going to be really odd for us to get started with this because we're used to seeing, the length of a segment, is, 2.7 inches or 15 centimeters. We're used to seeing things like that. We are not used to seeing algebraic expressions, which is the 2x plus 1. We aren't used to seeing that, algebraic expressions representing a length. But really all it's saying is that if I started at J and I went over to K, it would be officially 2x plus 1. So instead of officially being 15 inches or anything like that, it's going to be a 2x plus 1. So when I'm looking at this and I'm writing this, I'm going to write it as a 2x plus 1 right there. Okay. The next statement tells us that JH is 3x plus 2. So the length from J to H, the length of JH, that segment right there, if I were to measure it, again, it's very abstract because it's an algebraic expression, but if I were going from J to H, okay, it would be a 3x plus 2. Okay, so that's all it's telling me right there, and I'll get rid of that little arc so we don't get confused. Okay. And then last but not least, it's telling us that KH, the entire thing, is 53. Now that we're used to seeing. We are used to seeing just a plain old number. So from K all the way over to H is 53. Now it doesn't give us units, so we're not worried about, okay, inches or yards or centimeters or anything like that. But at least now we have our diagram complete. And our problem is asking us to find JK, JH, and KH. Well, hey, guess what? We already did one problem for you. We found one of those for you. We gave it to you. So it's 53. KH is 53. Okay. We do need to find JK and JH, but before we do that, we have to be able to find our expression, our value of x. So we have to be thinking, guys. We need to remember that, if I go from the end to some point, not necessarily in the middle, okay, but if I've got that from H to J, and then I go from J to K, it's the same thing as me going the entire way. All right, so little part plus little part gives us the entire part. And that's all we really have to do. I'm going to take this little part and I'm going to add it. Notice I'm drawing a really, really big addition sign right there in the middle of those two expressions because I'm basically taking everything to the left of this and adding it to everything of the right of that. And when I do that, it will all equal 53. So this actually has written my algebraic equation for me. Okay, if I start in the upper left corner and I just write what I'm reading, it's almost like you're reading a book. You're going to read across from left to right. I've got 3x plus 2, okay, plus 2x plus 1, and that has to equal the entire 53, okay, the whole thing. Again, small part plus small part equals the entire thing. That's the entire premise for segment addition postulate. Okay. Now once we have this, it is legitimately just an algebraic equation. We just want to do some chicken, lettuce, tomato, combine like terms. Okay, so I know that I've got a 3x and a 2x right there. I get a 5x when I combine those. I have a plus 2 and a plus 1. I will get a plus 3. When I combine those, that has to equal 53. I just bring that down. Okay. Inverse operations, I'm adding 3, so to take that out of there, I'm going to subtract 3. So I have a 5x, and of course that's gone, and that will equal 53 minus 3 is 50. So when I divide both sides, if I was multiplying by 5, to undo that multiplication I have to divide. And when I do that, I get an x equals 10. Okay, then I have to stop and I have to think, is that what the question was really asking me? Was I just supposed to find the value of that variable, or was I supposed to take that variable, which I need to take, and plug it back in to get the value of the segment lengths? Okay, so if I'm looking at this, JH I know is written as 2x plus 1. Well, if I do a 2 times our x we just found was a 10, so 2 times 10 plus 1, JK will give me a 21. JH is a 3 times a 10 plus a 2, 3x plus 2. 3 times 10 is 30 plus 2. I get a 32. And the nice thing about this, guys, is that you can actually double check. If you take 21 and 32 and you add them up, you get 53, which is the entire thing, which is what you were supposed to get anyway. Okay, I hope this helps. Remember, the other problems, 7, 8, and 8, 9, and 11 should actually be the ones that are very close to this. Okay, we'll go over the rest of them tomorrow in